folks. So we are in our lead up now to talking about the French Revolution. But before we can talk about the French Revolution, we have to talk about the Age of Enlightenment. The Age of Enlightenment was this period of rapid philosophical development where people started to think, hey, maybe it's not cool that the king exploits us and that rich people are in charge. And before we can talk about the Age of Enlightenment, we have to talk about the Scientific Revolution, because there's a direct line between the development of thought during the Scientific Revolution and the development of philosophical thought during the Age of Enlightenment. All right, so starting off with the view of the universe in the Middle Ages. So a lot of the scientific revolution is going to have to do with how we understand the universe. In the Middle Ages, we understood the universe to be geocentric. Geocentric means that the Earth is at the center of the universe. So that is what scientists, quote unquote, in the Middle Ages believed. So you'll remember previously that we talked a little bit about science in the Middle Ages and how science in the Middle Ages was really more a mix of superstition, alchemy, religion, and just kind of guesswork. They didn't have any sort of scientific method. They just kind of made a hypothesis and said, this must be true. There was no experimentation. And that's how we got things like the humors. Y'all remember that, and stuff like that. So, geocentric is easy to remember, so to keep you from getting confused, you can remember that geo means earth. That is the Latin root for earth, Greek, sorry. And so centric means center. So geo, earth, centric is at the center. So religion and the Catholic Church actually guided the geocentric view. So the Catholic Church said that God had actually put earth at the center of the universe, therefore the geocentric view. So here's a look at the geocentric view. So it looks kind of similar to our understanding in that there are, planets orbiting Earth. But the geocentric model looked like is you've got Earth at the middle, then you've got these concentric rings that are all the same size around Earth, and then at the very outside of all of the planets, which they did not think there were 9 planets either. At the very outside of all the planets, you have the stars, the heavens. So this is where heaven is. There's actually a physical location of heaven, and it is at the outside of the solar system. So Aristotle is the guy that we have to thank for this. Remember way back to when we studied ancient Greece, Aristotle was a philosopher and he was a big deal. And he actually influenced science, which I have in quotation marks here, for centuries. So Aristotle was kind of like the authority on scientific thought for a really long time. And he developed this geocentric model. Then this guy Ptolemy expanded on the geocentric model, and he developed what is called the Ptolemaic system. So don't say that P, his name is Ptolemy, ignore the P. So the Ptolemaic system is exactly what we just looked at, this image of the Earth at the center and then these concentric rings around it with the firmament of stars or the heavens on the very outside. So that's Ptolemy. So before the scientific revolution, as we talked about, science and medical development was just this mix of philosophy, religion, alchemy, magic, all of these very non-scientific forces. The ancient Greeks were kind of the scientific Bible. Ancient Greek philosophers influenced science, but the ancient Greek philosophers were philosophers. So their scientific method was pretty much logically reason something out, and now it's the truth. There was no experimentation or things like that, and that continued into the Middle Ages. If y'all will remember the Saturday Night Live sketch we watched, the Theodoric Barber of York, that's very much what science and medicine looked like in the Middle Ages. So the scientific revolution comes about around the same time as the Renaissance, actually. We didn't talk about it during the Renaissance because we focused more on the artistic side of the Renaissance, but there was also this big development of ideas and science and scientific thought starting with the Renaissance as well. So the scientific revolution was a period of rapid development of the way that we study the universe. So that does partially mean the universe like the universe as we think of it, so like stars, moon, planets, etc. But it also means the universe, like the universe around us, the world that we inhabit. So people no longer just blindly accept old authorities like the Catholic Church and the Greek philosophers. They're going to start to think for themselves, and they're going to start to experiment. So all of these new ideas and discoveries forward the scientific revolution. And normally, if we were in a lecture, I would say, how do you think the Catholic Church is going to feel about this? But I'm sure you figured it out. They're going to be pretty pissed. So the causes of the scientific revolution. The Age of Exploration had a big influence on the scientific revolution because new inventions are being developed that enable travel. People are going off and on expeditions and discovering new things and bringing that knowledge back to Europe. And also, just like we saw with the Silk Road, exchange of ideas. So as people are going out and learning from other cultures, they bring that knowledge back, and globally we are exchanging ideas and growing cultures. Now, as we've talked about, this really glorifies the Age of Exploration because there are also many negative things about the Age of Exploration. Just wanted to put that as a caveat. There, like I said, new inventions. So there were a great number of new inventions that largely were forwarded by the Age of Exploration as well to encourage travel, mapping the stars, things like that, that then also translated to scientific research. And as we talked about during the Renaissance, the ownership of knowledge started to transition from the church, who were busy having parties and by getting people to buy indulgences. So ownership of knowledge transitioned from the church to secular, meaning worldly, academic institutions. And these academic institutions promoted the study of science separate from the church and promoted spreading knowledge. Okay, so that brings us to the heliocentric model. So the idea of the heliocentric model, so helio means sun in Latin. I'm pretty sure Latin. So in the heliocentric model, Earth is just one planet of many. The planets all revolve around the sun. So again, the same way we remember geocentric, geo means Earth, helio means sun. So helio, sun at the center. So you can see here, we have the Ptolemaic system with Earth at the middle and the concentric rings and the infinite stars that are the heavens. And then we have this model, the heliocentric model, by a guy named Copernicus, who we'll talk about in just a second. So the idea of the heliocentric model, planets revolve around the sun, and the night and day are actually caused by the Earth's rotation around the sun. So this guy, Nicholas Copernicus, handsome devil, he was the first to develop the heliocentric theory. And because he developed this theory, he was actually excommunicated by the Catholic Church. He was not unexcommunicated until, I want to say, the 20th century. So remember, this doesn't seem like that big a deal to us now, like, oh, big deal, I got kicked out of the Catholic Church. But at this period of time, the Catholic Church is the ultimate authority. And so being kicked out of the Catholic Church, especially for developing a scientific idea, that's a huge deal and would have potentially even resulted in, Copernicus suffering higher ramifications if he wasn't careful. All right, then we've got this dude, Johannes Kepler. He's German. So Kepler took Copernicus's ideas a step forward, and he believed in using experiments and observation. So these scientific ideas are starting to sound more like what we understand science to be now, and using the scientific method. So Kepler said, he observed the planets, and he said, okay, you know what? I think that heliocentric model is definitely 100% correct, but I think that the planets actually don't move in perfect circles around the sun. I think they move in elliptical orbits. And this discovery is important because it's going to lead to the eventual discovery of gravity, to Newton's theory of gravity. All right, then we've got the man, the myth, the legend, Galileo Galilei. So Galileo's primary concern was, of what material are planets made? And so in order to study this, Galileo designed the first complex telescope. And he used this telescope to observe the planets and stars. So one of the things he saw was he looked at the moon and he saw mountains, or the ridges that we now understand to be on the surface of the moon. And so he said, hey, planets are actually not ethereal. They're not made of light. They're material. They're made of things you can touch, tangible things. And this was no good in the eyes of the Catholic Church, because the Catholic Church, in its dogma, said planets are ethereal. They're made by God. They're these beautiful, celestial, perfect things. And if they are made of material, of tangible matter, they're not perfect, and that specifically goes against Catholic dogma. So Galileo also preached that the heavens were fixed and unmoving, and that the sun was the center of the universe. Or sorry, the church. Sorry. So the church said that the heavens are fixed, the heavens don't move, and the earth is the center of the universe. And Galileo directly contradicts that. He says the sun. The sun is the center of the universe. But developing on those ideas of Copernicus and Kepler, the sun is the center of the universe, planets are moving in elliptical orbits around the sun, and planets are made of material matter. They're not this perfect godly substance. So the church is not pleased. Galileo was accused of heresy. We'll all remember heresy from when we talked about it during the Protestant Reformation. Heresy basically means that you've committed a crime against the church. So he was actually brought to trial before the Spanish Inquisition, and he recanted or took back his statements because the alternative was execution. So, why did the church care about Galileo? Well, Galileo was Catholic, and so it didn't look very good for the church that he was basically directly going against what the church said was true. The church had also lost a great number because so many people had gone over to Lutheranism, Calvinism, etc. Also, a lot of people's faith had been shaken because of these discoveries by astronomers and other Renaissance thinkers. And of course, Galileo's observations directly went against, church doctrine. All right, so next we've got Sir Isaac Newton. So Isaac Newton was interested in what explains the way things move in the universe. And so he developed the 3 laws of motion, which any of you who have taken or studied physics before, you know those 3 laws of motion. Objects in motion tend to stay in motion, etc. So part of this is the universal law of gravitation, which of course we refer to casually as gravity. Every object in the universe attracts another object. So Newton's idea of gravity and the laws of motion are really important because they would be the basically authority in the field of physics until Einstein came around with the theory of relativity. Okay, then we've got Sir Francis Bacon. So Bacon basically said, okay, just guessing at something and then saying it's true is not a good way for us to figure things out. Instead, we should observe and use inductive reasoning to then make an experiment and test our hypothesis. Does that sound like anything you've heard before? It should, because he developed the scientific method. So you have used this in every science class, hopefully, that you've taken, especially since middle school. So the scientific method is observe, research, make your hypothesis, experiment, analyze, and then write your conclusion. All right, so all of these minds are really important, and as we're going to talk about in our next lecture, they are going to then inspire the people of the philosophical enlightenment who are going to take these ideas of how the universe governs itself and apply them to philosophy.